morning, everyone. I'm Carson. It's a pleasure to be here, especially considering that it was snowing as I was leaving Minneapolis yesterday, so it's nice to get away from that nonsense and enjoy the good weather here. And I'm here today to talk to you about my work at Plotly, and I work on the R package. And I really view this as a tool for analysts to help them with their exploratory visualizations. So I'm going to try to show you some examples, give you some theoretical foundations for what motivates my work, and hopefully you get something out of it. And I have this slide deck up here at bit.ly/PLOTCON17-talk if you want to come back to some of the links in here at a later time. So to put into context what I mean by exploratory visualization, I really like this diagram by Hadley Wickham and Garrett Grolemund. They sort of concisely convey the minimal aspects of what goes into really any sort of prototyping data science workflow. No matter what you're using, you have to import your data somehow into your program. You're probably going to tidy it up in some way. And then there's this iteration of data transformation, visualization, modeling, because you're not going to know right away what you're looking for, of course. So this iteration is what I'm going to be talking about mostly, of this data transformation, visualization, and modeling. And then once you sort of have your insight in hand, then comes the communication phase. And of course, the web is now the preferred medium for this. And I'm probably not alone in this room in thinking that Plotly.js is one of the best choices for quickly getting an interactive graph with some nice interactivity and helping convey your idea to a wider audience. But just looking at the whole ecosystem of interactive web-based graphics, to me, there's a shocking lack of tools for analysts to really explore on their own and prototype new ideas where you can quickly do data transformation, do statistical modeling, machine learning algorithms, and visualize and generate new views of your data to find the view that you're looking for. So what ends up happening is data scientists have to juggle all these technologies. You might do your data analysis in R or Python, and if you want to take advantage of interactive web-based graphics, in some cases you have to learn some JavaScript or D3 or Plotly.js. And this is actually a real-life depiction of me deciding that I'm going to learn D3 and JavaScript in my second year of my grad program. I just completed a PhD in statistics, so I think a lot of these sort of ideas where, I love this quote by Brian Ripley, it's all too easy for statistical thinking to be swamped by programming tasks. So me, as someone developing tools for data scientists, I want to help you focus on your data analysis problem and not on programming. And I experienced this firsthand and spent like 6 to 12 months just developing one interactive visualization. And let me tell you, I arose from this swamp. You guys, believe me. And I said, I will drain this swamp. But I'm not actually that arrogant. I do have some lofty goals, but really the focus is, putting a tool in the hands of statisticians, data analysts, and we're not going to try to require them to know anything about web technologies. And we want this tool to work with other tidy tools in R. And that will help sort of minimize this iteration phase between data transformation and visualization. And I also want to make it easy to declare interactive techniques that support common data analysis tasks. And there's some caveats to this, because the scope for this is quite huge. I want roughly maybe 80% to be easy, i.e. it doesn't require that you know much about JavaScript, but make the remaining 20% possible if you do know some JavaScript, or you do know something about the internals of Plotly.js, or how to work with it in JavaScript. And I also want to focus on interactive techniques that puts the power in the hands of analysts. And I think they fundamentally have different needs from, say, a general audience, where you want to restrict your interactivity in some way when you're communicating an idea with someone else. But when you're actually exploring data, you want something a little bit more flexible, where you can prototype a lot of different ideas. And let's not forget that statisticians have been attacking this problem and thinking about this problem for 50+ years. It goes all the way back beyond John Tukey, when he was at Stanford physics lab, talking about using dynamic graphics to visualize high-dimensional physics data to identify high-dimensional geometric structure that their naive statistical models were missing. So they were using dynamic graphics to visualize this high-dimensional structure and identify structure. But again, it's easy to get lost in the sea of techniques for interactive and dynamic graphics. So I really like this paper by Cook and company, where they motivate a taxonomy of techniques based on common data analysis tasks. And the first one is finding gestalts, which really means finding the right view of the data, posing queries. So think about interactively performing an SQL query via a graphical interaction, and also making comparisons. So making maybe multiple queries and making comparisons between them. And not everyone needs to diagnose a statistical model. But I think this last bullet point here, generate insights faster, can really connect with everyone, because we all need to get stuff done. And I think now that we're sort of in an age where data is becoming more and more accessible, this is really important. Where, I mean, speaking as someone who has a training in formal mathematical statistical models, I think there needs to be less of a focus on that, and formulating mathematical models to test exact questions, and more of a focus on flexible tools where you can ask approximate questions and get quick answers. So again, there's really two main components to generating faster insights to me, especially in this application. And when you're going through this iteration of data transformation, generating a new view, you find out that view is not quite right, you want to look at something else, you transform your data, you visualize again, you're going to most likely be working with a programming interface. So you need good glue between those programming interfaces, because most of your time gets swamped down by iterating from phase to phase. So you get, some output from a model, and then, it takes you hours to figure out how to actually look at that model results, or you look at a graph and you get an idea for something else, and it takes you forever to figure out how to transform that data and get a new plot. So that's one component to this, is the quality of the glue between the programming interfaces. And then in context to interactive graphics, you also want good glue between actual graphing interfaces. So we would like to be able to have a Plotly graph talk to, say, a leaflet graph or another open source interactive web-based library. So I'm going to show you an example of, I found this tweet last week where this visualization kind of blew up on Reddit and social media. And I think there's two components to why it did blow up. One being that it just looks kind of beautiful. And the second being that this plot was generated with just 14 lines of R code. So if you look at this R code, this is, if you just ignore the highlighted lines here, it's using some of the tidyverse, which is sort of I guess, a niche thing within R, but it's basically tools for working with data in an opinionated way. And so the first chunk here is just like transforming the data, cleaning it up, and then if you, again, ignore the highlighted part, it's using ggplot2, which tens of thousands of people use to do exploratory visualization, and that would generate that static plot that you saw earlier. Now, if I just do two things where I basically add an attribute to the data here, which basically tells the system, if I interact with this graphic, I want to select or basically make a query where I filter by the latitude that I've selected. And then if I give that ggplot2 object to this function ggplotly, that converts ggplot2 to plotly. And then I also have some additional options for the type of selection mode that I want to use when actually interacting with the graph. So this is the result that you get. And a couple things that I get for free is the ability to hover over the lines to see specifically what the population was at that point. And I also get the ability to zoom in on specific regions. And again, what we did by adding the attribute to the data saying I want to query a latitude, that allows me to click on specific lines to highlight that specific latitude. And then I can zoom back out, and that might be useful for, say, seeing if a bunch of people live at a specific latitude. So I guess the highlighting or the brushing technique here isn't super useful in that example, but it is once we extend it to this idea of multiple linked views. So this is an example where I have, hold on one second, there's a video here. So this is data that I have on the county level of the proportion of people within that county that voted for each candidate plotted against population density. So what you can see right away, even with a static graphic doing something like this, you could say, well, more densely populated counties tended to vote for Clinton, and less densely populated counties tended to vote for Trump. But one thing I do see here that I would like to investigate further is why there's so many counties around 0 for Jill Stein. These counties down here don't really seem to fit the general trend. So what I could do is use the zooming and panning ability to, and then I sort of see that there's some discreteness going on with this data, and then I change basically the mode of the click and drag interaction to a brush, and then I can immediately see geographically where these counties lie. So it's a way to basically isolate an interesting subset of your data and then visualize how that data looks in multiple dimensions, more than just 3. And also with keeping all of the data plotted there, it's a little bit more powerful than just like a filter operation where you can't see the rest of the data. You can compare like a marginal distribution to a joint distribution. So this is more for, I guess, some of the developers in the room, but this object GG is just think of it as like a faceted plot that you would create with ggplot2. We have some nice easy options to, like I did with the first example, persistent selection, which means basically accumulate all the things that I'm selecting rather than forget about the last one. Dynamic basically means to populate this color brush widget so that I can change the color of the selection interactively. And also populate a selectize widget, which is tied, it basically updates when I do, say, select a year in a time series. This is median house prices by month for different years in different cities. So when I select a year, it updates for all the cities, so you can compare a specific city, or sorry, a specific year across cities. And then the ability to dynamically change the color allows you to make comparisons. And notice how when I do a direct manipulation to update the plot, the widget automatically updates, and I can do it in the other direction as well, where I can make a selection that way. These years, I think, are missing in some of the data. And then you have complete control. If you know some of the Plotly.js specification, you can completely, you could use transforms to summarize the selection. You could use, in this case, I'm just adding a marker to the line so that it shows a symbol so that I can actually see which specific points there are in the data that I have. And we can also link with animations. And this is an example where I'm linking like a tree dendrogram to what's known as a grand tour, where I'm essentially interactively selecting a number of groups in an unsupervised classification problem. Here choosing 4 groups. And then with the grand tour, you can think of it as, well, it smoothly interpolates between random 2D projections of the data, which gives the effect of looking at like a high-dimensional data structure. So it's a nice way of sort of diagnosing how your model fit looks. And we can also link to other widgets. So in this example, we're linking Plotly to a leaflet plot, where I can do some filter operations with slider widgets. So I could filter down to a number of stations. This is earthquake data. But this also works with the brushing type operations that I was showing earlier, where you could color points different colors to make comparisons. If I could, there we go. Just to show you real quickly the code. The main point here is the same data structure is being used as the input to everything you see in that last view. So this sort of thing really wouldn't be possible otherwise. And I think this can be a really powerful idea for you people that might develop tools out there that are centered off data. If you can get the community to sort of agree on a central set of data structures and build your tools upon those data structures, then the community can do some really cool things where, you know, I wouldn't be able to link to a leaflet plot if the author of leaflet wasn't willing to build upon this data structure. So building as much semantics in your data as you can, and then building pipelines from that data is, I think, a really powerful idea. And of course, all this work is standing on the awesome work of other people. Toby was actually the original author of the R package, and of course, all the people who work on ggplot2, I'm using Hadley to signify a lot of people. But of course, as well, the Plotly.js crew, they are willing to always answer my dumb questions and fix bugs that I complain about and implement new features that really make all of my work possible. So shout out to those guys. So yeah, this is impossible without a lot of people. And that's all I have, so I'll stick around for questions if you have them. Yeah.
The mapping example you showed me, does the interactivity also work from leaflet back to?
Yes. So
Can you please repeat the question?
yeah, so the question was, I did some interactions where the source of the selection was coming from the Plotly graph, and then it targets the leaflet map. The question was, can I do the reverse thing with leaflet? And I haven't tested this, so I hope it works. But yes, there's this little box here where you can bring up a brush. Not sure why that's not updating. Oh, yeah, because it's in persistent mode, so it'll basically accumulate the selection. So, yeah, and another thing I'd like to point out too is, this sort of thing has always been possible thanks to a tool in R called Shiny, which is a way to program web applications from R. But we're doing this in such a way that we're taking Shiny out of the loop. And this is, all the examples that you've seen here is standalone HTML. So it makes it very easy to share these visualizations. Whereas with Shiny, you need an R process running in the background, and that makes it very difficult to share those visualizations and host them. There are some pretty good services out there by like RStudio, where you can, for free in some cases, host your applications. But with something like this, you have a lot more options for how you want to embed them and that sort of thing.
So just real quick, what is the roadmap on the R side?
Good question. So I showed you my contrived example of converting the ggplot object to Plotly. I would say roughly like 80 to 85% of what you can do with ggplot2 maps to Plotly. And that's just looking at the ggplot2 API itself. And now we're seeing an ecosystem of tools being built to extend that API to other R packages. So there's an official extension mechanism to create new geoms, new layout algorithms. And I have provided an official extension mechanism where other authors can plug into ggplotly if they've written a new geom. It's pretty easy to just write a plugin, and there's a few people who have done that. My goal for the end of the year is to get like 99% of ggplot2 converted correctly, and I think we can achieve that. And then once we get there, then I want to start focusing on some other interesting projects like ggRaf, or I think it's pronounced ggiraf, and some other interesting ggplot2 extension packages. But of course, hand in hand with that, a lot of this stuff that I've just shown you today is pretty new, and there's some things I think that we could do to improve it in terms of probably performance, number one, and maybe providing some additional options as well. Okay? Good. Thank you.